All right, we're going to go ahead and do section 2.2, more on functions and their graphs. So the first thing we want to talk about is behavior of a graph, where it's increasing, where it's decreasing, or where it stays constant. So looking at our first graph, we're going to start over on this left side. So this is going all the way to negative infinity. So we're going to say from negative infinity all the way up to 0, all the way up to 0. That graph is constant. Then it looks like we're going to say from 0 all the way to infinity. So we're using that x-axis. All the way to infinity, it looks like we're increasing. So just tell me what's happening in a graph. Looking at the next example. So again, we're going to start with this left side. So this goes all the way, we're starting at negative infinity over here, right? Because this is going to keep going and going and going. So negative infinity all the way up to negative 1. We're going to be increasing. Once we get to negative 1, it looks like from negative 1 to positive 1, we're decreasing a little bit. And then once we hit 1, we start increasing all the way to infinity. So 1 to infinity, we're going to be increasing again. All right, moving on. Maximum and minimum. So obviously these graphs both continue on forever and ever. So when we're talking about a relative maximum, relative minimum, it's the maximum of what you see here, obviously knowing that this goes to infinity as well. So your highest point and your lowest point on your graph. So it looks like we have a maximum and a minimum. So your max is at 2, 4, and your min is at 0, 0. Domain and range, just so we can practice that. So your domain, remember that's your x coordinates. Looks like, again, this graph is going to keep going and going. So we're at negative infinity all the way to positive infinity. Your range, remember that's your y coordinates. So low as we go, negative infinity, and as high as we go, positive infinity. You could also say all real numbers. Moving on to the next one, we got a parabola over here. We got that parabola, the quadratic. Let's start with, we don't really have a maximum, but we do have a minimum. So it's okay not to have one. So our minimum, our relative minimum is at 0, negative 4. Domain and range, so domain is, again, that negative infinity to positive infinity, and our range, it looks like negative 4 all the way to infinity. And yes, you can equal negative 4, so make sure you use that bracket. All right, moving on. It also talks about intercepts. I forgot to mention those. Remember, you have two types of intercepts. You have x-intercepts and y-intercepts. So x-intercepts are on your x-axis, so it looks like our x-intercepts are at negative 2 and positive 2. And our y-intercept is at negative 4. Good. All right. Even versus odd. Even functions, basically, if you look over here, it's an even function if you plug in a negative x, and the function winds up being the same function in the end. Odd functions, it turns into a negative version of what you saw to begin with. So let's look here. So we're going to find out what f of negative x is. So everywhere you see an x, we're going to plug in negative x. negative x squared becomes x squared plus 6. So see how this was the same as the original? That is going to be an even function. The next one, we're going to go ahead and do that same thing. We're going to find g of negative x. Plug in that negative x, see what happens. So we got negative x cubed, and then minus negative x. So here, negative x cubed is actually negative x cubed times 7 gets me negative 7x cubed. Negative minus negative becomes plus x. So see how this is the negative version, right? Negative 7x cubed plus x. So this is actually an odd function. And last but not least, h of negative x. We're going to see what happens. Negative x to the 5th plus 1. Negative x to the 5th is negative x to the 5th plus 1. Now, this one's a little weird. So part of it changed to negative, but part of it did not. So this would not qualify for even or odd, so that would be a neither. If you are asked to identify from a graph, even functions are going to be symmetrical about the y-axis, so you can flip them over the y-axis. Odd functions are the origin, so that's 0, 0. And then moving into piecewise functions. So a good example, it says a cell phone company offers the following plan. $20 per month for the first 60 minutes, and then 40 cents for every additional minute. So it says C is your total cost, and T is the time in minutes, and create a piecewise function. So we're going to say cost based on minutes, right? How much time? And we're going to start a piecewise function. So notice piecewise because it changes, right? For the first 60 minutes, you're locked in at $20. So our function, our cost is going to be $20 when our time, right? When our time is between 0 and 60 minutes. So we're locked in at 20 bucks. Now, if we go over 60 minutes, we're going to be adding 40 cents a minute. So we still have that $20 flat fee plus 40 cents for every minute. But remember to take off those first 60. So we're going to take our minutes and subtract off the first 60. So that will give you every additional minute. And again, this is only if your time, your minutes, is greater than 60. So you have two different areas where you could be using a different formula. The next part says go ahead and find your cost for 40 minutes and find your cost for 80 minutes. So if I'm talking about 40 minutes, I'm in this first function, right? My time is between 0 and 60. So if I'm paying for 40 minutes, I'm actually going to pay $20 regardless. Anything below 60, anything 60 or below, sorry, is $20 flat rate. Good. Now, 80, we're going to be using this second function. We're going to be using that second function because we're greater than 60. So what do we got? We're going to have 20 plus 40 cents a minute for however many minutes I went over 60. All right, so we're going to have 20 plus 40 cents. We're going to have 80 minutes, take away the first 60. What do we got? 20, 40 cents, 20 minutes. So it looks like 40 cents times 20 minutes is $8. And you're going to be paying $28. All right, moving on. And last but not least, graphing piecewise functions. So again, you're working over an interval. So this first one says basically it's 3 for every x value less than or equal to -1. Less than or equal to -1. So if x is -1, y is 3. If x is -2, y is 3. If x is -3, y is 3. And so we're going to go ahead and finish that off. We're going to keep going this way forever and ever. So that was if x is less than or equal to -1, your y is 3. Now this one is if x is greater than -1. If x is greater than -1, then y is x minus 2. So we actually have to plug that in. So we're going to go ahead and plug in -1 first. So x and our function. So remember this is x minus 2. So if x is, we'll find out what -1 is. So -1 minus 2 more gets me -3. Now remember x has to be greater than. So we're going to come to our graph and we're going to graph -1, 1, 2, 3, but we're going to put an open circle. Because remember we can't equal that point. We want everything greater. So now pick something greater. And this could be whatever you want to plug in. If you want to plug in 1, 2, 3, whatever. Let's try 2. So we're going to plug in 2. 2 minus 2 is 0. So we got 2, 0. And we're going to head in that direction forever and ever. And you could have picked any point, again, greater than -1. All right, so that's it. Thank you guys.